Okay, so today I'm going to do a little lesson, first lesson on C# programming. We're specifically using Visual Studio 2011, but you'll be able to get the same, whether you're using 2005 or 8 or 10, it all works out to be the same. We're going to kind of go at somewhat of an accelerated pace, just so that we can get as much done as possible, kind of hit the fine points, and then future lessons we might come back in and fill things in, plus do some other things. Okay, so what we're going to do is I've created a class called Lesson1, and anyway, it created this file here, and it dropped in some using statements. This block up here, these using statements, are basically namespaces that you can import, and over on this side over here where there's references, anything that's inside of any of these libraries inside of this references tab that you've decided to import are available to use, and all you have to really do is basically say I'd like to use it by using these using statements. That allows you to basically use whatever namespace is contained in that library. So we're going to build inside of this namespace lessons. So basically the code is going to consist of classes, and a class, let's just start out with a class called animal. So what we're going to do is we're going to kind of build upon the principles that each lesson is going to kind of build a little bit and do some certain things. So I'm going to talk about inheritance probably in the next lesson, how different classes can inherit other classes. So we're going to start out with this base class of animal. And you can kind of think of the class as a blueprint for the object to be created. Inside the class, basically there are properties and methods. Usually the properties are first, but they don't have to be. It's just a convention. If anyone else is going to look at your code, that's what they're going to expect. You can think of a property as some sort of physical attribute of it. Something that, such as, for example, we're talking about animal here, public class animal, so we could just say public string. We might have the name of it, right? So I'm assuming that you're coming to this from somewhat of a programming background. There are different types that you can use. This right here would be the type, string. It's a string type. And string is basically like a bunch of characters, put together. We generally, in the English language, we refer to those as words. There's other things like integers, Boolean, and then, in fact, there's several different types of integers. You can get int32 for a 32-bit integer, int64, int16, different ones, and then there's some other ones. String and bool are the ones that you'll end up using quite a bit, and these are called built-in types because they are not something that they're kind of built into the compiler. They're not a type that you create. Like, for example, this animal right here is also a type. It's a class, so this is also can be considered a type. Sometimes you'll hear them referred to interchangeably, classes, or what type of variable is that. So type refers to this right here. Public, you can either have public, private, protected. Generally the ones I use are private or public. Public means you can see it outside of this class. Private means it's going to be just inside of this class. Is the only place that will be accessible is just inside of the class. So that kind of gives it its scope of what can see it. Okay, let's do another one. Let's just say an age of an animal. Maybe doing this on the fly, so some of these might be kind of strange. But anyway, so there's a couple of properties. That'll probably be good for now. The next thing you can have are methods. So methods come next. Same with this thing, you have public, private. I'll go ahead and type this out and then I'll explain the different pieces of the method which are important. Let's see here. Let's do it this way. Okay, so this is the method. As you notice, it looks a little bit different than the properties, of course. It has a few different pieces to it. This piece over here is the return type. So whenever this method executes, this will be what is returned. You can also think of this line right here as, a lot of times it's called the signature of the method. And what you put in here is what will be seen when the user tries to call this method. They will see this so that they can know what they'll need to pass in. This right here, these are called parameters. And these are what you'll be expecting to pass in. So right now I'm just expecting one string to be passed in. This right here is a local variable that is only used inside of this method right here. So for example, it will be called elsewhere. Another piece of code will call this talk method. They're going to pass some string in. When it gets to this method, it's going to turn into this variable right here. So it could be called something completely different, but inside of this block of code, you know, the method block, it's going to now be referred to as that. So it basically you can keep the same variable name, but you don't have to. That's kind of what that's about. Okay, so let's just let's see here. This is easy. Let's just write out to console, and we'll just write those words out. So right here we're also, you know, calling another method, and guess what? If you hover over it, you can actually see where this comes from. This comes from a class called system.console. So it's inside of this system namespace right here. These are basically just namespaces. All these are namespaces just like this. So if you wanted to see everything that's available for console, a couple things you can do. You could just type it out, and you've got this whole list here. Or the other option, you can right-click on it and go to definition. Now, since this is assembly, or since it's compiled code, we're not going to see the full code. We're just going to see the signatures of the methods. Remember how I was saying these are signatures. So we're going to see just the signature of it. We're not going to see the full piece of code. So if we come down here, this is the class console. We've got all these properties right here, and basically a get and a set. A get means give me the value of it. A set means set the value of it. Properties and fields are very similar, but there is a big difference. And these are called properties. A field, if we flip back over to the code, kind of backtracking here, but a field would be something like this. Very similar, but they do behave differently. So a field would be something like this. So if I just say, oh, let's see here, what do we want to have? Okay. Let's just say the genus of the animal. So this is a field. Notice that it doesn't have this block of code right here. It doesn't have a get and a set. A field is kind of a loose way of doing this, except for you don't really have control over it. Like, you're going to basically have no control. It's going to be able to be accessed, you know, change the value, anything's going to be able to change the value of it, whatever. So it's kind of a very loose control, and generally considered somewhat bad to have a public field. Generally, you want to do down below, the stuff below, if it's going to be public. Now, it's totally fine to be private. In fact, what happens when these get created, this is kind of a shorthand, and what the compiler does is it turns this into two different pieces. It actually creates a field, and it's either going to be like a lowercase name, or so it basically creates a field out of this right here, and it lets you access that field. It actually creates a private field that can be accessed right here. But I'm not going to bore you too much with that. That's just kind of the difference between fields and properties. You might be wondering, why in the world would I ever use properties? I kind of wondered that when I was beginning. But the reason why you'd want to use properties is it allows you a lot of control. If you only want someone to get the value of something but not set the value, then you simply delete the set. So now you've basically turned it into a read-only property, because the set is no longer there. So it allows a lot of control. Plus, these are kind of shorthand, but if you wanted to do something specific with a set, so for example, every time that someone set the name, if you wanted to capitalize it, then all you'd have to do is do something like this. Is upper. I don't use 2upper that much, but so basically that's all you'd have to do in order to set. Get rid of that right there, make it a little better. To set the value, you can just do something as follows. There, make it format a little better. So it allows a lot of control for your variables, which can be very nice, and that's the reason why they're used. So I'll back this out of here. And put these on this single line just so that this looks a little bit better. I generally like to have those all together. Okay, so we have this class, and it's got a couple properties and a method. So let's go ahead and use this class. Now if we come over to, right now we've got a little form here, we've just got a little button, and this is actually from some other lesson, so I'll rename this. And we'll click on this button here, and it'll take us to this piece of code that's going to execute. We're going to kind of gloss over some of the big things, because right now we're just interested in classes. We're not going to talk about events and all this stuff right now. We'll get to that later. It's important that you understand classes and objects and the difference between the two. So like we said, the class is a blueprint for the object whenever the object's created. So when we create this object, so we can, since we're in the same namespace, see how this says namespace lessons? This is also the same namespace. We can directly create an animal by just referring to that type or that class. So we do it as follows. Animal, and you notice it pops up right in the IntelliSense, so you know you've got access to that class. If it didn't pop up in the IntelliSense, you might want to start looking, okay, have you imported the namespace using those using blocks up above. You notice that it appeared. So it shows up. Okay, so let's explain this line right here. This is called object instantiation, also called, creating an object, whatever. Generally called object instantiation, instantiate an object, lots of different things. Okay, so let's just go through the different pieces of this. When you create an object, there's a couple things you need. So on this left-hand side over here, we have the type. Up here we have the variable name, right? So we have and I'll put these in blocks so that it's kind of easy to see what's going on. This is how you do it. So you tell it what type of object is this variable going to refer to. And over here, you actually create the object on this side over here. So this new animal is actually creating the object. This piece right here, you might wonder, what is that? That calls the constructor. So that basically is a method that gets called in this animal class. If you come over here, we do not have a constructor. Constructors are generally done somewhere in here between properties and methods. Sometimes they're above properties, but generally I like to put them after the properties. And a constructor is code. It's basically a method that gets called right when the object gets created. So it's kind of like this initialization phase of the object. And what you do with this is you have to call it the same name as that, as the type. Oops. And then it's kind of similar to a method signature, but you notice there's no return type. It's just blank. So give me 1 second. Okay, I'm back. If you do not explicitly create a constructor, then one is created for you at compile time. You never really see it. It doesn't really matter to you because it will be created. These are those empty brackets that you're seeing. It's basically calling this right here, new animal. Notice that this signature looks identical to this signature here, but nothing happens. So you basically just create this object. There's no extra initialization. So you can actually get rid of this constructor if you don't use it. Some people like to keep them in there for convention. Another thing is that you can actually have two constructors. You could have one that actually took some parameters. You might actually say, you know what, I would like to set the name and the age right when I create this. So let's just create one here real quick. And oops. Let's just show you what that's all about. So you can just say name equals name and age. Oops, equals age. So this would be a constructor that is setting the name and the age, which can be useful because, so let's get rid of this one that's not doing anything. Let's just keep this one right here, which can be useful because sometimes I'll show you both the different ways that it can be done on the code side. Some people like to have this to just go ahead and set some initial values for themselves when they create it, which is very nice. Basically, we're passing these values in. We're going to refer to name as the string, and age as the int that come in. So these are the values coming into the method. Name is then being set to this name right here, which, as you can see, it's different capitalization. Capitalization matters big time. I mean, these are completely different variables, even though they have the same name. One's lowercase, one's uppercase. Okay, so this one right here is referring to this property. So what it does is when this gets called, it sets this name. When this age gets called, or when this age comes in, then it sets the age for the particular object that you're creating. So that object can be thought of as this entity that's out there that has been created on disk. It's sitting out there. It is not this blueprint right here. You can't get confused. The object is a living, breathing thing. You can change the values of the property. You can run methods. It basically maintains some sort of state. In fact, you can create 2 of these animals, or 3 or 4 or 5, any number of animals, and that's generally the reason why you would create a class, is so that you can create more than one of those types. And the closer that you think of them as real-world objects, the better off you'll be. Think of this as a blueprint. Think of the object that gets created as an actual object out there. that can be modified and changed. So anyway, enough of that. Let's take a look and see what we can do with that constructor. Now it's barking, it's saying that animal does not contain a constructor that takes 0 arguments. So there's no constructor that exists that takes 0 arguments. You have to include something here. Because we went ahead and created this constructor, it's expecting that we pass a name and an age into it. Now, one thing that we can do is we can create another constructor. You can actually have as many constructors as you want, just kind of like method overloading is what it's called. Overloading when you create 2 methods with the exact same name but with different signatures. And the signature, as you remember, is this right here, the return types and the parameters. So we can create another constructor that doesn't take anything at all, a blank one. So we can either create an animal that's not that doesn't have some sort of initialization or constructor, or we can go ahead and pass the stuff in, and it knows how to handle both types. You notice down at the bottom our errors went away, 0 errors. If we come over here, we have no more errors, gone. Okay, so let's go ahead and, since we created that constructor that allows us to pass stuff in, we can go ahead and pass stuff in. If we hover over this, it says we got one overload. And the cool thing is, what I usually like to do is if you get rid of those parentheses and go ahead and type them back in, it says there's one of 2 types of constructors that we can call. We can call this one here that doesn't take anything. See how there's no parameters, or we can call this one here that takes a name. A string. We should focus on the integer. The types. A string, and then the second parameter, is an int. So all we need to do is pass a string and an int in, and then it'll initialize up to those things. And we can see what they are based on the first one was the name, and the next one is an age. 34-year-old dog. Okay, so this is perfectly fine, and we're completely happy with this dog. Let's just create a little bit more stuff here for this talk method. In fact, what we're going to do is when we run this talk, we're going to call upon the name of this animal. So if you think about this new object that's been created from this class, the current object that's been created can be referred to with the keyword this, meaning the current object that is whatever object is running this method, because now we've created this dog out there. This current animal that's been created, this current object, we can refer to with the keyword this. And as you notice, it gives us a list of things that we can do with the dog. We have its age, and properties are shown by this little wrench right here. So we have age and name. Those 2 are referred properties because we can tell by the icon. The icons are useful to kind of tell what it is. You can also see that this talk method that we created appears as well. It is in a box, meaning that is a method. So it will tell you what it will give you the method signature if you hover over the method. So it tells you the signature of that method, which is nice. It also has some other methods that were inherited just because it's an object. Every class has a base, inherits base of object. So that's where it picks up these extra methods that we did not create. We didn't create any of these, but because all objects come from the base object, which is kind of a tongue twister there, they automatically get certain attributes to them, certain methods and attributes, just because that's what they are. Okay, so if we want to say this is my age, and we want to say, actually that's the right line here. My age is, so the right line is going to go ahead and include a carriage return. Oops, you know what, I did these backwards. Okay, so that should print out the name and the age. And this is probably not going to buy off on this because I'm trying to add together a string with an integer, and you can't do math like that. You can't add a number to a word. Not in C#. You can do it in other languages, but not in C#. So we're going to turn that into a string before we add those together. Okay, but we don't want to get too distracted away from this objects here. So now that we've created this object, let's go ahead and have it talk. And what it wants here is, if we look at the signature, it wants us to pass in a string. You can kind of forget about the variable name. The variable name is not super important. That's kind of mostly used as kind of a reminder. Okay, what is this string going to be? You know, it's going to be, oh, it's going to be words. Okay, so it's just kind of more of a help. The important thing is that the type, it's going to be a string that we're passing in. So let's just bark because we're a dog. And let's see what happens here. As you know, we kind of did this a little bit weird because we actually don't use the bark, and the output is coming to our console, which I believe shows up. Let's see, I believe we need to actually open the console window up to get that. I usually don't use console and forms together, so give me one moment and I will find that. Let me see if, yep, there it is down here. Okay, so it's this output window, because I didn't want to go into talking too much about forms just yet. We're just talking about simple classes and objects. Okay, so actually it does put bark in there because probably more than likely we actually have it in here. Oh yeah, I forgot. We actually are telling it to just write out whatever you pass in. Just write it out. So the console. So this is the console right here. And so it did what we expected.